So our last topic is acid-base titration. And what a titration is, acid-base titration in particular, say we have an acid, we don't know its concentration. We have a base, we do know its concentration. We add base to the specific volume of the acid until we achieve the neutralization point. And we can tell when it's neutralized. We put in a color indicator. Usually we use phenolphthalein, and when it just starts to turn a faint permanent pink, we know it's been neutralized. Given that data, then we can determine the concentration of the acid. So, and to do that, we use stoichiometry. So let's take a look. So here's a titration here. So we've got 42 milliliters of a 0.15 molar NaOH solution neutralized 50 milliliters of a hydrochloric acid solution. We don't know the concentration of the acid. That's the whole point of doing the titration. So we want to know what the molarity is. So here's our reaction. You got to have the reaction, right? And it's a balanced reaction, right? 1 mole of hydrogen chloride reacts with 1 mole of sodium hydroxide to give us the products of neutralization of salt and water. So what we do with that balanced reaction, first we determine the number of moles of NaOH that were reacted, right, using molarity, right? We've got the concentration, we've got the volume. The volume we can quite easily change to liters. Then from there we can determine the moles of the HCl just using proportions. We know it's a 1-to-1 ratio from our balanced reaction. So however many moles of NaOH are reacted, that's how many moles of hydrogen chloride are reacted. And then once you have the number of moles and we know the volume of the hydrochloric acid, right? That was a fixed volume we had in the beaker. We didn't know, because the concentration of the hydrochloric acid is unknown. We didn't know how many milliliters of NaOH are going to be required. So now we know after doing the titration. So we take that number of moles of the acid divided by the 50 milliliters converted to liters, and that'll give us our molarity. So let's see how we do that. Those are our steps, so to speak. So the number of moles of NaOH is just going to be M times V, right? We saw that rearranged earlier. So we got 0.15 mole per liter times. Now notice what I did with the volume. I didn't count back 3 decimal places. I just multiply it by 10 to the minus 3. So all you got to do with your calculator is just go 42, hit your scientific notation button, which is EXP or EE or whatever, and just put in your minus 3, and there, you've got it converted to liters. So, and we've got 6.3 times 10 to the minus 3 mole of NaOH reacted. So therefore, right, because of the 1-to-1 ratio, 6.3 times 10 to the minus 3 mole of hydrogen chloride are reacted. Right, so we've got the number of moles, we've got the volume, that was predetermined when we set up the titration. We'll be doing a titration as a lab. So our molarity for the HCl is just going to be its number of moles. And again, I use that same thing. Rather than count the decimal places and, risk counting too many or too few, I just multiply by 10 to the minus 3. So again, you can just go 50, hit your scientific EE or EXP button, whatever it happens to be, put in the minus 3. Now you've got it in liters, and we wind up with 0.126 mole per liter. So that's the concentration of the acid. And just to finish off, so that you can see we use stoichiometry as part of the titration process, right? Once the titration has been done, then we have to do the calculations.